Hi guys, in this presentation we shall learn more about I2C protocol. In this presentation we will learn how to write the function for write and read. Okay, so before that we have to clear our basic concepts, so that I have a video that is how data is transferred from master to slave, or how data is read. Okay, I have detailed explanation in the first video, so we'll just recap it. See, whenever we have a clock pulse, okay, whenever the clock is low, we have to put the data on the STA line. Whenever the clock is high, we have to take the data from the STA line. Okay, so using this I have to write the write function. Okay, so how I'm gonna, what is my approach? See, whenever I want to write something on the date on the line, we should have some data, right? So the function need a parameter in which I'm gonna pass the data. So I can write like, see, void, see, I don't see this function doesn't return anything. Okay, just I am writing the data on the STA line. I'll name the function as I2C write. Okay, I'll pass a parameter called data, okay, which is of unsigned char data. Okay, so since this data consists of 8 bits, okay, we need to transfer the data either from MSB to LSB or LSB to MSB. Okay, so in this protocol it is clearly mentioned that we have to transfer the data from MSB to LSB. Okay, now how to transfer the data? So before transferring the data, we should know something, that while we put the data on the line, okay, consider this is an STA line. Okay, while we put the data on the STA line, we have to make the clock low. Okay, at this condition only we have to put the data. So what I'll do is I'll make clock as 0. Okay, if I make clock as 0, then I can put the data. So at this place I'll put the data. We'll see how to put the data, and after that I have to make it high to take the data. Okay, so at this position, whenever the clock is 0, after making clock 0 I'll put the data, and then I'll make the clock 1 to take the data. Okay, so this should be done 8 times because the data is of 8 bits. So I'll run a loop. Okay, I'll run a loop from I equal to 7, I less than or equal to 0. So see here, this loop runs 8 times. So in 8 times we have to send bit by bit. Okay, that is the actual idea. So how to transfer the data? See, the point is the data is stored in this variable data. Okay, I have to extract each bit and put the data on the STLN. So how to do that? Before doing this, we have to know some basic operations. Okay, that is bitwise operation and AND operation. I have already made a video on bitwise operators, and there is a video called set and clear bits also. You can watch those. I'll in brief I'll explain here. See, this is the truth table of AND. Okay, now you can observe some things here. Whatever the input, either 0 or 1, if you AND with 0, the result is always 0. Okay, whatever the input, if you AND with 1, the result is always the same number. Okay, you can observe here. So we use this logic to extract the bits from the data and put the data on the SDLN. So how we can do that? See, suppose for example I have to send the data like 1010 1001. So this is the data I want to send. Then you can see that this is the MSP and this is the LSP. So I want to extract this first bit, and so first bit is 1, right? So I have to put that 1 on the SDLN. So how can we do that? The data, which is this data, and I will shift this, since it is in 7th position, I will shift this 7 times to the right. So after shifting 7 times, my result will be 0 0 0 0 0 0 0 1. Okay, so I got the 1 there. Now what I'll do is I will use these logics to get the data. So how can I do that? I'll use simply a bitwise AND operator. Okay, I'll put AND operator and AND with 1. So if I put 1, by default all zeros except the last one. Okay, like this. and 1. Okay, so remember one thing, this one represents this, okay, which means no matter, okay, what the numbers are here, okay, these here the bits are always 0, because by this observation you can say that no matter what the number is, if we AND with 0 we'll get 0, so here all we get zeros. Okay, now what is the data here? It depends on this value. Okay, if this is 1 we'll get the data 1, if it is 0 we'll get the data 0. So what I mean is, whatever the data is, suppose if I shift this number 6 times, then I can simply say that my answer will be 0. How? Because see, if I shift this 6 times, I'll get as 0 0 0 0 0 0 1 0, right? And if I AND with 1, I'll get the result as 0 0 0 0 0 0 0 1. Okay, by this logic you can say that these rest of the bits are 0. Okay, because the bottom bits are all 0, no matter what the number is at the top. If we AND with 0, we'll get the always these answers as 0. Okay, now this is the important factor is here, the 0 is there, so we'll get the answer as 0. So by this procedure we can extract the data from the 8 bit into 1 bit. Okay, so I have to do the shifting, right? First I have to shift this 7 and then 6 5 4 3 2 1 like that. So that's why I have written the condition, I have written the loop like from 7 to 0. Okay, now data is shifted I times. Okay, first 7 and then 6 5 4 3 like that, and I have to AND with 1. So after getting the data, I have to put this data on the SDA line. Okay, so I'll put the data on the SDA line. Okay, so this is how to write a write function in I2C write. Okay.